To synthesize high-quality speech, text-to-speech models require high-quality audio samples. Ideally, the audio should be recorded in a professional studio with a minimum sampling frequency of 44.1 kHz. The speech signal's bandwidth should be at least 13 kHz, with a signal-to-noise ratio of at least 32 decibels. There should be no mismatch between audio and reference texts. Additionally, to facilitate the TTS research, audio data should be diverse and contain both male and female voices, with a minimum of 15 hours of audio per speaker. We analyzed existing English datasets for training TTS models and found that none of them fulfills the above requirement completely. In the paper, we introduced Hi-Fi TTS Dataset, a new multi-speaker English dataset for training text-to-speech models. It was created from LibriVox audiobooks and Project Gutenberg texts. It includes audio recordings of 10 speakers, 6 female and 4 male speakers, with a minimum of 17 hours of speech for every speaker. The audio recordings, including in the dataset, were carefully selected from all available English LibriVox recordings based on audio quality analysis. Specifically, we estimated frequency bandwidth and signal-to-noise ratio across multiple bands to guide the speaker selection process. The LibriVox readers were sorted based on SNR calculated for the most recently added book, and only the readers with the highest SNR values were considered. To verify that the selected speakers are a good match for the Hi-Fi dataset, we performed spectrogram analysis and listened to a sample from every book of a reader. After selecting the initial set of readers with acceptable audio quality, we calculate SNR for all the books of the selected readers, since we observed the readers' audio quality may differ across the books. Based on SNR, we included books that have low noise and high frequency bandwidth into the clean subset of the dataset. The books with noticeable noise and narrower bandwidth are added to the other subset. TTS models require audio samples to be no longer than 20 seconds, so to split the original LibriVox recording into shorter clips, we use the NEMO CTC segmentation tool based on segmentation algorithm proposed by Kurzinger et al. To make sure there is no mismatch between texts read by the readers and the reference text, we run inference with multiple ASR models and disregarded samples with word rate greater than 0. We use NEMO Speech Data Explorer tool to analyze the data and inspect individual samples. Both the CTC segmentation tool and Speech Data Explorer are open source as part of the NEMO framework. The dataset is freely available at openslr.org.